Okay, good evening to all. Aliphatic nucleophilic substitution. Today we are going to discuss about aliphatic nucleophilic substitution. So, what is nucleophilic substitution? In this topic, we have to discuss first of all attacking reagent, that means nucleophile brings electron pair to the substrate and form a new bond that with another nucleophile, that is another meaning nucleofuge, so that having electron pair on the leaving group, so that will be depends on the substrate, nucleophile, leaving group, all the conditions are suitable, that product will be formed in a full form. So alkyl halide, for example, here this equation, alkyl halide ORX, that will be reacts with nucleophile, give the product R Y. So that is the final product, and the X is the leaving group. So always leaving group we shall choose chloride, bromide, iodide. These are all the leaving group. Next we are discuss about the reactions such as mechanism following uh, this type of nucleophilic substitution reaction. So how they will attack the alkyl halide, and second step and the single step, that will be give the product in the intermediate, that will provide the product with the leaving group from the total product. So here nucleophile attacks on the backward of the carbon, that will pull the carbon in the backward position. At the same time, leaving group will be left out from the compound. So that this will produce the initial stage, that will produce in the single same step. Intermediate will be found. So that will be having such a dotted lines. So that is known as the intermediate product, and at the afterwards the at the end of the stage, the nucleophile um, nucleoph leaving group will be get detached from the compound. Then Walden inversion. What is Walden inversion? Here the one of the example we have to go through. So what is that? The that will be alpha plus or minus phenyl to propanol. So in this molecule, alpha rotation, that will be positive rotation on this molecule in presence of tosyl chloride, that will produce such a product in the following type. So this also similar to the previous explanation. So in this same molecule, that will be provide in the product in the alpha rotatory form. Another one is the crossover experiment. Here you have to uh, treat the starting material in presence of base, that will abstracts proton from the carbo carbon carbon carrying methylene compound. So that will be converted as the carbon ions. Here that product will be produced, the final at the final stage, that will be proceed at the final stage, that will proceed the product in the crossover experiment. So these are all the evidences for the proof in the confirmation of SN1 mechanism. That will be aliphatic nucleophilic, or either aromatic nucleophilic substitution. These are all the evidences to prove such a mechanism through the following examples. Next, aliphatic nucleophilic substitution carrying two type of mechanisms, that is SN1 and another thing is SN2 reaction. Here SN2 substitution nucleophilic bimolecular mechanism. So that is known as SN2 mechanism. Here the backside attack is possible to convert the following reaction. So here a nucleophile attack the substrate from the backward position with the angle of 180 degree away from the X. So these are all the one step process. In the one step process that will taking intermediate formation of intermediate, and another thing, and that formation of intermediate, from the formation of intermediate, a leaving group will get detached from the total composition and to the providing a product. So these are all taken in a one step process. So here there is no intermediate, and energy of ACY bond formation, which is equivalent to energy of CX bond dissociation. So formation bond formation, which is equivalent to bond dissociation. And also transition state reached central carbon through sp3 hybridization, whether sp3 hybridization or sp2 hybridization overlap with the nucleophile. So these are all the SN2 mechanism. So carried out, these are carrying two-step process, that is known as another thing, that is known as carbonium ion process. So carbonium means carbon carrying positive charge. Here the one more first step is the alkyl chloride, that will be break down into dissociates into alkyl carbonium cation and leaving group, split into two different charges. And another thing, second step, that carbonium ion will get attached to the another nucleophile and produce the product in the following way of or Y. So rapid reaction between intermediate and nucleophile. So here this is the combination in between carbocation and nucleophile charges. So here the ionization assisted by solvent. Either that solvent will be only base component. So departure from the front side, that will be limiting of the reaction. So that will be proceed such a minority of the minor compound will only will which will be get from this part of front side attack. So back side attack only provide a major product of composition. And another thing, SN1 carrying the following type of evidences also. So the first one is kinetic evidence, that having both nucleophile and substrate involved in the rate determining step. That is another thing, it is called as slow step. So second order, it also follows kinetic in the following second order reaction. So reaction rate, which is equal to rate constant, that is associated with the Rx, concentration of Rx and concentration of nucleophile. So if excess nucleophile provides, that means which also known as pseudo first order kinetics. So rate is associated with the concentration of leaving group. So rate constant depends only the concentration of leaving group. So next, Walden inversion. In this point, substitution at a chiral carbon, which will takes inversion of configuration. So what is chiral carbon? That means carbon carrying four different functional group on this type of carbon. So inversion of configuration will be take over. So inversion means, that means carbon carrying four different functional group through the center of the carbon, that will be inversion will take place. That will the reciprocal of the way of attachment will be possible here. So path A B, that is having either path A B, that is carrying a negative and positive side. So both sides will be appear on this molecule. So that this is one of the inversion of configuration. So negative side, that will be imposed like positive and negative sides. So two types of inversion will be occurs here. So base treatment in the, for example, base treatment with alpha tosyl orthotoluene sulfonate molecule, that will be implies the following and proves the following SN1 reaction, and lead abstraction of proton. So base abstracts the proton from the starting material. So carbon attacks the methyl group in the internal SN2 process. So here also the crossover experiment shows carbanion attack methyl group of another molecule. So here the reaction prefers intermolecular condensation type. So intermolecular, that means in one molecule that reaction will suitable on the carbon attacks methyl group of the another molecule, the same molecule that will be so intramolecular and intermolecular, type of two different molecular type will be implies this mechanism, and theoretical and experimental evidences that will be applicable for the SN2 reaction intermediates in the same way. Next way that will be applied in the following type of mechanism. Here the mechanism that is implies the following way of techniques. So the following graph shows the aqueous solution that will be gradually decreases and suitably reach the height. That graph will be reach the height at the suitable particular point, then gradually suit up to the increasing way. So here from aqueous solution to gas phase, SN2 reactions will be possible in the increasing way of method. Next, SN1 evidences also implies the following examples. That means solvents include water, acetic acid, ethanol. All the following suitable solvents will induce the SN1 reaction, and one of the example is implies here. So that is known as tertiary alkyl chloride, and the first step that will be known as the rate determining step. So another way that is known as slow step. So here the formation of carbocation, tertiary carbocation will be formed with the leaving group will be detached from the molecule, and also in the second step that tertiary carbocation reacts with base one, for example potassium hydroxide or sodium hydroxide, and anything strong or weak base that will be induce the first step, so driven the first step that will be provide tertiary alcohol will be in the final product. So these are all the examples for the SN1 mechanisms.